Hudson have entered into a collaborative agreement with Invion to develop their Photosoft technology as an indication for ovarian cancer therapy, and with a view to developing it in other disease types as well. The main findings thus far from our research have been the mechanism by which Photosoft and IVX-P02 actually induce cancer cell death. We know now where they localise to within the cell. We know how long they take to get in and out of the cell. And we've also established that they have significantly lower toxicity in the absence of activation than other photosensitizer compounds. PDT, or photodynamic therapy, involves delivery of a photosensitizing compound into cancer cells, followed by activation using a particular wavelength of light. And that causes irreversible damage and kills the cell. Photosoft and IVX-P02 are amongst a family of what we call chlorine-based photosensitizers. We know now that they move into the cell and localise to specific compartments where they induce what we call reactive oxygen species. And that causes damage to the cell, results in cell death. Both Photosoft and IVX-P02 work in the same way. They're taken up by cells and they localise to specific subcellular compartments. Now at this point they are completely non-toxic, so prior to activation they have no effect on cells, which we believe means that they're going to be quite safe for use in patients. They're subsequently activated using a specific wavelength of light, and as soon as they're activated they cause very rapid and irreversible cell death to kill cancer cells. Now in laboratory testing we've found that both Photosoft and IVX-P02 are actually substantially more effective at killing cancer cells than several other sensitizers we've tested. And in fact, the IVX-P02 compound exerts around a 15-fold increase in the efficiency of cell death. Over the course of our testing, we've found that the IVX-P02 compound works at roughly a 4-fold lower concentration than the Photosoft oral. And then in cell death assays, using the same concentrations of both compounds, we actually see about a 15-fold increase in cell death using IVX-P02. We perform these assays by growing cancer cells in a dish. We add the compounds and allow them to be taken up by the cells, and then we activate the compounds. And the number of cells that are remaining following activation gives us an idea of how many cells die, or the potency of the compounds in the cells. I think there are two very important aspects for the subsequent development as an indication for ovarian cancers. The first is the absence of toxicity prior to activation. So most photosensitizers that are on the market do have some toxicity, and patients previously have had to remain in dark rooms or be protected from light for extended periods of time after they've had these compounds. We're not anticipating that is going to be the case with Photosoft or IVX-P02. The second thing is that because, particularly with the IVX-P02, it seems to be far more potent, means we can use lower doses to get the same effects, or it means we can use an increased effective dose and get more complete tumour ablation or a more complete response in patients. So I think both of those things will be important as we progress. So the next stage for the research is we're moving into a preclinical mouse model of ovarian cancer, and we're hoping to demonstrate both direct tumour destruction and also induction of anti-tumour immunity. Once we have that data, we'll be moving towards first clinical trials very soon.